Hello everyone, today we're going to tackle a question that has fascinated humans for centuries. How many stars are in the universe? This seemingly simple question is, in fact, a complex puzzle that has been studied and contemplated by astronomers and astrophysicists across the globe. It's like trying to count the grains of sand on a beach, but a beach that's ever expanding, and where each grain of sand is a flaming ball of gas millions of miles away. The answer is not definitive. It fluctuates due to numerous factors, including the vastness of the universe, its intricate structure, and the ongoing expansion that stretches the cosmos further every second. These elements add layers of complexity to the task, turning it into an interstellar enigma that we're still trying to solve. But don't let this deter you. Quite the opposite. It makes our quest even more exciting. Every step we take in this journey offers a deeper understanding of our cosmos, its grandeur, and the celestial bodies that adorn it. So buckle up as we take a journey across the cosmos to understand the star-studded universe. First, we need to understand the concept of the observable universe. Imagine standing in the middle of a vast field under a starry night sky. Now imagine that field is the universe. But here's the catch. You can't see the entire field. You can only see as far as your eyes, or in this case, our most powerful telescopes allow. That's essentially the idea behind the observable universe. The observable universe is the sphere around us, reaching as far as the most distant objects we can detect. It's not necessarily the entirety of the universe, just the part we can observe from our vantage point. Picture it like a bubble, with us at the center, and everything we can see within that bubble is what we call the observable universe. Now, within this observable universe, there are mind-bogglingly vast quantities of galaxies. A galaxy is a massive system that can contain billions or even trillions of stars, along with all sorts of celestial objects like planets, asteroids, and nebulae. In our observable universe, the estimate is that there are about 2 trillion galaxies. That's trillion with a T, an almost unimaginable number. And remember, each one of these galaxies can contain hundreds of billions of stars. But here's the thing. The size of the observable universe isn't static. It's constantly expanding. As time goes on, more of the universe comes into our observable range. That means that the number of galaxies, and consequently, the number of stars we can observe, is always increasing. Now that we understand the observable universe, we can start to make some estimates. To estimate the number of stars, we start by looking at the stars in a single galaxy. Now let's take our very own Milky Way as a case study. A swirl of mystic lights, the Milky Way is our home in the vast expanse of the universe. And within this celestial home, it's believed that there are about 100 to 200 billion stars. Yes, you heard that right. Billion with a B. Imagine each of these stars as a blazing sun, just like our very own. Some of these stars might be smaller, cooler, and redder, while others are larger, hotter, and bluer. Then there are those that are so massive and luminous, they're hard to fathom. Yet, each one is a unique player in the cosmic game, playing its part in the grand scheme of the universe. Now let's try to visualize this. Imagine you're standing on a beach, looking out at the sand. Each grain, tiny and seemingly insignificant, represents a star. Now think about this. There are more stars in our Milky Way galaxy than grains of sand on that beach. Mind-boggling, isn't it? Yet, even this astronomical figure represents just a fraction of the total number of stars in the universe. The Milky Way, after all, is just one galaxy among an estimated 2 trillion galaxies out there. Each of these galaxies, just like our Milky Way, is a star-studded spectacle, a celestial party with its own guest list of billions of stars. So, if we consider that each galaxy has a similar number of stars as the Milky Way, the math becomes truly staggering. Just think about it. If one galaxy holds this many stars, imagine how many stars all the galaxies in the universe might contain. With an estimate of the number of stars in a galaxy, we can start to make some calculations. Indeed, the total number of stars in the universe is an estimate, a guess, if you will, derived from some mathematical calculations. Scientists take the number of galaxies in the observable universe, which is thought to be about 2 trillion, and multiply that by the average number of stars in each galaxy. Now this average is a considerable figure, standing at about 100 million stars per galaxy. So imagine this, 2 trillion galaxies, each with an average of 100 million stars. The numbers are staggering, aren't they? If you're scratching your head trying to figure out just how big that number is, you're not alone. Even our best mathematical minds find it challenging to comprehend. The total star count estimate in the American system is 1 septillion. For those not familiar with such large numbers, that's a 1 followed by 24 zeros. In the European system, the number is 1 quadrillion, which is a 1 followed by 15 zeros. But remember, these are just estimates. The universe is continually expanding and evolving. New stars are born and old stars die. So the actual number of stars could be much higher. And there's another factor to consider. Many galaxies are too far away, too faint, or hidden behind dust clouds, making them invisible to our telescopes. This means that there could be a vast number of galaxies, and therefore stars, that we are currently unable to observe. So the total star count of 1 septillion or 1 quadrillion is a rough estimate. It's our best guess based on the information we have at hand, and it's likely a conservative one at that. However, this is likely a conservative estimate. There is still so much we have yet to discover about our vast, beautiful, and mesmerizing universe. Counting stars isn't as straightforward as it seems. You might think that we could simply tally up the stars in all the galaxies we can see, and voila, we would have our answer. But it's not that simple. There are some significant complications that come into play when counting stars. Firstly, the universe isn't static, it's expanding. This means that as we're counting, more universe is coming into existence at the very edges of our observable universe. This new universe could contain new galaxies, which in turn could contain new stars. So while we're trying to keep count, the universe keeps adding more. Secondly, space isn't flat. It's curved by the mass of galaxies and dark matter. This curvature bends the light from distant stars, which can lead to the same star being observed in multiple places in the sky. This phenomenon, known as gravitational lensing, can potentially skew our star count. Additionally, the universe is not only incredibly large, but also incredibly ancient. The light we observe from distant stars has been traveling for billions of years to reach us. This means we are seeing these stars not as they are now, but as they were when their light first started its journey. Some of these stars could have died out in the intervening years, which further complicates our star count. Lastly, not all stars are equally observable. Some are obscured by dust clouds or their own brightness, while others are so faint or so far away that their light is difficult to detect. So even within the observable universe, not all stars are necessarily observable. Despite these complications, scientists are continually working to refine their estimates. They use increasingly sophisticated tools and techniques to account for these intricacies, all in the pursuit of answering that seemingly simple question: how many stars are there in the universe? Science never rests, and neither does our quest to count the stars. In this relentless pursuit of knowledge, we have launched various missions, one of which is Gaia, a space observatory of the European Space Agency. This mission is playing a pivotal role in our understanding of the cosmos. Gaia's primary objective is to survey and create the most detailed 3D space catalog ever, charting roughly 1 billion astronomical objects, primarily stars in the Milky Way. This is no small feat, considering our galaxy alone is home to an estimated 100 to 200 billion stars. The data gathered by Gaia is invaluable. It's not just about counting stars, it's about understanding their positions, distances, movements, and changes in brightness. This information helps astronomers uncover the composition, formation, and evolution of our galaxy. But Gaia isn't working alone. There are other missions too, all contributing to this grand celestial census. These missions employ a variety of techniques to observe the universe, each adding its own piece to the puzzle. Astronomers are also looking forward to the launch of future missions. With advancements in technology, These missions promise to be even more accurate and detailed in their observations. Every new mission brings us one step closer to understanding the vastness of the universe. In the grand scheme of things, our home, the Earth, might seem insignificant compared to the cosmos. But it's from this tiny rock that we are reaching out, extending our knowledge, and trying to grasp the scale of the universe. We are not just counting stars. We are understanding our place among them. These missions bring us closer to a more accurate count of the stars in the universe. So, how many stars are in the universe? The answer is, we're still not entirely sure. But let's take a moment to wander back through the cosmic tapestry we've been weaving in our minds. We started with our own observable universe, this vast expanse of space and time, home to an estimated 2 trillion galaxies. That's a number so large, it almost loses meaning. And yet, it's a crucial part of our celestial equation. We then looked closer at a single galaxy, finding that each one on average cradles around 100 million stars. That's a lot of suns, a lot of planets, and a lot of possibilities. But again, these are just averages, estimates. The actual number could be much higher or somewhat lower. Our journey then took us to the daunting task of estimating the total number of stars in the entire universe. An estimate that hovers around 1 septillion according to the American system or 1 quadrillion in the European system. But remember, these estimates are likely conservative. The real number could be even more mind-boggling. We also delved into the complications that make star counting such a challenging endeavor. The universe's expansion, the curvature of space-time, these aren't just abstract concepts from a sci-fi film. They're real factors that scientists have to consider when trying to answer our initial question. And finally, we touched upon the ongoing missions like Gaia that aim to provide more precise data on star populations. These missions, while ambitious, are the torchbearers in our quest to understand the universe and our place within it. So, while we may not have a definitive answer to how many stars are in the universe, we have an understanding of the complexity of the question and the continual human effort to find an answer. It's a cosmic journey, and it's one we're all a part of. Thank you for joining us on this cosmic journey. Please subscribe for more videos exploring the mysteries of our universe.